Thank you for joining this lesson. We're going to handle a question on longitudes and latitudes. The position of town A and B on the Earth's surface are 36 degrees north and 49 degrees east, and 36 degrees north, 131 degrees in the west, respectively. Find the difference in longitude between town A and B. Now, between town A and B, we can see even from the statements that they are on two supplementary longitudes. If this is the primary, this is the 0 degrees prime meridian. Remember, it is the prime meridian where all the other longitudes are named. Then we have 0 degrees equator. This is 0 degrees equator. It's again from the equator where all the other latitudes are named. For example, we have 36 degrees in the north. This is 36 degrees north. That is where the two places lie. One is on the east, 49 degrees. 49 degrees in the east. This is 49 degrees east. And the other one is 131 degrees in the west. So 131 degrees in the west. That means now the intersection of 36 north and 131 in the west should give us our B, and 36 north and 49 in the east should give us where point A is. Now, difference in longitude is from 49 in the east all the way to 36 in the west, to 131 in the west. That means the longitude difference is going to be 49 plus 131. This is 180 degrees. We add the two because they are on opposite sides of prime meridian. If they were on the same side, like east and east, we would have subtracted to get angle difference. If they were on the same side, west to west, we would still have subtracted to get the angle difference. But now that they are on opposite sides, we add for us to obtain the angle difference, or rather the longitude difference. Given that the radius of the Earth is 6370 kilometers, calculate the distance between town A and B along parallel of latitude. Parallel of latitude. This should be parallel of latitude. Yeah, that must be a typing error. Parallel of the latitude. That is from A to B through the latitude where they are. And that means distance on a small circle. A latitude is a small circle. That means now we should know that there is a formula to give us distance in kilometers on a small circle. For a small circle, this is given by theta out of 360 2 pi r cosine of the latitude of the two places, where the two places are lying. Theta is 180 out of 360 multiplied by 2 multiplied by pi multiplied by radius of the Earth cosine of 36, because they are on latitude 36. Let me compute this and give the distance in kilometers. 180, this is 2, this is 22. You can also multiply by 6370. The cosine of 36 divided by 360 by 7. This gives us 16,100 196.5 kilometers. That is the distance along the parallel of latitude. Then we have distance along a great circle, that is along a longitude. Now it should be noted that when we are having two places on, like there, on two supplementary longitudes, the distance along a great circle means distance along the poles. This is distance along the poles. Can also be called the shortest distance. In a different language, you could have been told to calculate the shortest distance. The shortest distance. So the shortest distance in this case, is going to be along the pole, and that is the North Pole for this case. So from A, along the pole, then down through the other longitude to B, that is a great circle, and that is the shortest distance. So I need us now to get that. I need us to get that distance. Remember, if we take this one as the equator, 0 degrees, and now we have a place along should know this thing. This is the North Pole. But now along the North Pole, I'm saying when we move through 49 in the east, when we pass through the North Pole and we continue moving, we usually go down through 131 degrees west. You see? So moving from a point on longitude 49 in the east, we should go down, if we continue after passing the pole through the same line, through the other longitude, which is supplementary to this one, and any other longitude, it applies the same. If you are moving along 150, you could have gone down through 130, such that the two should have 180. Now we are moving from 36 degrees here, 36 degrees up to 36 degrees, a point at 36 degrees to another point at 36 degrees. So from 0, 36 degrees to the north, and from 0, 36 degrees to the north. This is where A is, this is where B is. So this is the arc length we want. That is the arc length we want from A to B. That is the arc length we want to get the distance for. Therefore, we can take 180 and we subtract 36 times 2, or rather 72. This is going to be 108. So this is the angle we want, 108 degrees. 108 degrees. So now, distance along a great circle, whereby the angle at the center is 108. That means now we're going to say distance in kilometers along a great circle is given by data out of 360. Then we use a 2 pi r, strictly 2 pi r. So the angle at the center of the arc is 108 divided by 360 times 2 times a pi of 22/7 times 6370, the radius of the earth. 6370, the radius of the earth. So 108 times 2 times 22 times 6370, then we divide by 360 by 7. This is going to be 12,012 kilometers exactly. This is the exact distance along the great circle. So that is how we obtain the distance. Finally, Another town C is 840 kilometers east of town B. East of town B. On the same latitude as towns A and B. Find the longitude of town C. So now from B and towards the east, we move 840 kilometers, but we don't know up to which point. So we want to know that longitude. So we should know that from B to C, we are moving along a parallel of latitude, or rather along a small circle, and the distance has been provided in kilometers. That means we use the formula that we applied in part 1 here, that distance is theta, and for our case, the theta is known, because from B, we don't know we are moving to what longitude. We don't know. So we can say the theta is unknown in this case, but out of 360, when multiplied by 2 pi r, then the cosine of the latitude, this one is supposed to give us a distance of 840. So we know the formula, it's only the theta which is unknown. For us to remain with theta, or rather the angle difference, let me use my calculator so that I take 840, I multiply with the denominators here, 360 and 7, then I divide by the numerators, which are 2 by 22 by 6370, the cosine of 36. This is going to give me 9.335 degrees. So the angle difference from B to C is 9.335. 9.335. And remember, we are moving from B, which is 131. This is 131 in the west. Now we have moved such that we are still on the west, because coming to the east, and we have not covered more than 131, it means we are still on the west side. But now we have narrowed towards 0. 9.35. So what longitude is going to be this? What longitude is going to be this? Because we are finding the longitude of town C. So the longitude of town C will be 131 minus 9.335. So 131 will take us to 121.66. Can have it as 0.7 to 1 decimal place. So this is 121.7 degrees in the west. That is going to be the longitude of town C. 121.7 degrees. 121 in the sense that now, if we were to find this change in theta, we would have taken now, because they are on the same side, 131 minus 121.7, that would have taken us to 9.3. So that is how we get the longitude of town C. Some other times the examiner will tell you to find the position. That question will be different. So far we are correct. So if we had been told to find the position, now we would have stated with, we begin with the latitude, then 121.7 in the west. This could have now been the position of C, but it is not our point of concern. We just wanted this.